Today's Fort Collins Comic-Con panel with Carolyn Collins Petersen. She is going to be telling us all about Mars, because if it's February, it must be Mars. Cece, as she's otherwise known, is also a science writer, producer, and the head science talk wrangler for Fort Collins Comic-Con. Her latest book, Discovery of the Universe, just came out early on in the pandemic, but don't hold that against it, because it's a fantastic book, like most of her work. Cece also produces shows that you might have seen at the Fort Collins Museum of Discovery and the Dome Show. And she's just such a fantastic part of our community. We're so thrilled to have you. Cece, take it away.
Great, thank you. Thank you, Nick. It's really good to be here, and I'd like to say hello from the slopes of Mount Sharp on Mars. Actually really in the, right near Rollinsville, Colorado, so I'm talking to you from a couple hours away. Yeah, it's been several years since I started doing these talks. I also bring people to Denver Starfest, if you go to that. And so Ken Carpenter, who was here earlier, was one of the people who I've been bringing out every year to talk. And I thought he might like to do Fort Collins when we were still going to do it, you know, in person. But so he came and showed up. And then Aaron, you all know about. And then tomorrow we have Dr. Claire Raftery, who is a fantastic person to talk to us about the sun. So, and then we'll also do a sort of an Ask Me Anything about science, like no terribly personal questions, but anything about science tomorrow afternoon. So without any further ado, I'm going to try and share this. So let's see if, oh, I just lost something. Hold on, guys. I've lost, hang on. Aha. You know, I've been doing Zoom now for weeks. You would think I would have figured this out. Let's see here. All right, can you see a picture of a little girl?
We're with you.
All right, so I'm going to go back to the beginning. This is, I like to talk about Mars. I've been talking about Mars for a number of years, and when I was a kid, I thought I was going to live on Mars. Well, first I thought I was going to live on the moon. That didn't happen. So then I thought, well, all right, I'll set my goals a little bit higher and we'll go to Mars. This picture that you see here under the words Quest for Mars is actually a drawing, a set of maps made by a 19th century astronomer named Giovanni Schiaparelli, who was kind of one of the people that helped shape our view about Mars before the early 20th century. And I always was kind of fascinated with that name, and I started looking it up, and I found out that he was also related to the Schiaparelli fashion house. So if you wear any Schiaparelli, you're wearing something from a family that also produced a Mars explorer. Anyway, so yes, I'm Carolyn Collins Petersen. I'm the space writer. There's my website if you want to visit it. I have a blog that I write on fairly often, and I'm also on Facebook and Twitter at the space writer. So Mars has had this huge presence in cultures all around the world, probably since the first people could really go outside and look up at the sky. And so for ancients, thinking of it as the god of wars, to science fiction books, to stories and movies, we can all think about, movies like The Martian or the Mars books. It's only been since in the last couple of hundred years that it's really become an object of intense scientific scrutiny. People sort of moved it from the realm of being a god to being this thing that we could study kind of like Earth. And of course, today we have spacecraft on Mars. We have spacecraft orbiting Mars, and there's a flotilla of 3 of them headed to Mars. So before I get to describing those, I want to talk a little bit about the history of Mars observations and what we've learned about it over the years. When I was a kid, we used to play going to Mars. We had this big piece of flat cardboard that we put out in the field, and we would all stand on it and we'd jump around and we'd make rocket noises, and then suddenly we landed on Mars. It was really our alfalfa field, but when you're a kid, you have this great imagination. But that was our launch sequence, and we would spend hours exploring this red planet and talking about Mars. And I don't really know where that came from, because I was probably 7 or 8, and there was only 1 or 2 missions that had gone to Mars by that time, but somehow it just stuck in my brain. And the game was such an integral part of our lives that I never really forgot it. And it became a part of a really important video that we did for the Smithsonian Institution a few years ago. And this is an image, this is a still from the movie. That little girl's my niece. And she is now in her early 30s and has 3 kids. But at the time she was 8 years old. The show was called Sky Quest, and it was a story about a little girl who grew up to be an astronomer. And as part of the show, we actually recreated this old Mars exploration game. And this still is showing that. We actually had her build a cardboard rocket. And she got in there and she rumbled around and she finally landed on Mars. And when she got out, everything was red. And she had all the same kind of adventures that us kids did. Talking about Mars, we would, look around and see if we could find monsters. And if you'd ask us back then, what does Mars look like? We'd have said, well, it kind of looks like that alfalfa field, and there's water and there's monsters and all this stuff. Red alfalfa, red trees, pink sky. But that was the Mars of our dreams. And it looked a lot like Earth because that's where we were. Well, this is what Mars really looks like. And you can see, I don't know if you can see me or not, but in the picture that I have behind me is a picture of the same mountain. I'm on the flanks of it. This is from the Mars Curiosity rover, and it's where people will actually someday walk. I would love to go walk across that because it looks just like someplace that I've hiked here on Earth. Future Martians are going to go to a desert like this doesn't have any air that they can breathe. There's hardly any water and there's no life. So you have to ask yourself, why do we want to do this? And I think a large part of it is we're just so fascinated with this planet. We're fascinated with another world. And it's a lot like Earth in many other ways, as you can see. You look at that picture from Curiosity of Mount Sharp, and it could be any desert on our planet. So to give you some perspective on this is the central peak of an impact basin where something plowed into the surface. And the impact basin is called Gale Crater. And Mount Sharp is about 10 miles away from the rover in this image. And so you can kind of get a sense of the perspective. In the foreground, you can see there are rocks, there are ridges cut out in the slopes of the peak. It just looks really, really familiar. It looks like you could go out there with a bucket and just pick up sand and take a look at it. The bigger story here is that the pictures like this really tell us that Mars is a planet. It's a real world, it's the world next door, and it's someplace that we want to explore. Here's an image of the foreground, a really close foreground of the Curiosity landing area. It's very dry. There's lots of rocks. Some of them look like they have layers in them, like sandstone. If you go up in the foothills, west of Fort Collins or Boulder or someplace like that, you'll see sandstone up there. But it also looks like there's some volcanic deposits. And we know from the history of the region around here that there was also volcanism going on in the past. And so it's pretty clear in many places on Mars that it also happened there. And again, it looks really familiar, especially to anybody who's been to a desert. But the bigger story here is that, again, pictures like this tell us that Mars is a planet. One of Curiosity's jobs, if you're let me back up. If you're a geologist and you go out in the field and you want to learn something about the rocks, you're going to dig those rocks up. You're going to have a bucket. You're going to have a pickaxe. You're going to have a lot of stuff. You're going to dig into the surface. And one of Curiosity's jobs is to be our little geologist on the planet. Curiosity is the most active one on the planet right now. And it studies the rocks. So in this area where the spacecraft was, it found a mineral in the rock. It studied the rock and it kind of ground into it and did some spectroscopy on it. And it found a mineral in it called feldspar, which is a very common mineral here on Earth. If you go up in the mountains here and you look around, you might find some kind of pinkish rock with some white flecks in it and maybe some black flecks. That could be feldspar. It's very common here. So we know how it formed here on Earth, and that tells us how it formed on Mars. And this is just the beginning of the rover's geology mission. The big question about Mars, though, is not just the rocks. It's also about water. And so it was pretty exciting when the rover returned this image. Now, this looks like a rock in a stream bed. Again, if you go up hiking in the mountains here and you see these kind of rocks that look like they're all jumbled and cemented together, those are called conglomerates. And they're just exactly what they are. They're conglomerated together. They get cemented. They form when smaller rocks are cemented together in an area where water's been flowing. The water kind of stands and pools, then it dries out, and there are chemicals in there that cement the rocks together. So these conglomerates form. So this rock, this picture, was the first time we actually saw evidence of such a conglomerate on Mars close up. And it was basically evidence of places where water had transported rocks on Mars. Now, as I'll show you later, we'd actually seen flow features on Mars from orbit, but this was up close and personal. This is what a geologist would do if you're out in the field and you're picking up these rocks and you go, yeah, that looks like a conglomerate. And then you might tell what the individual rocks are as you go on in your study. So these were carried along in a stream and they then settled to the bottom of the stream bed and then cemented together after it all dried out. The sizes and shapes of the rocks that are cemented together offer some clues to the speed and the distance of that long ago stream. So a high speed flow of water will carry larger rocks. I'm not sure how many of you remember the floods that we had here in 2013. I live at the top of, and just on the other side of Coal Creek Canyon, and that road was pretty much just blown away. And as we drove along, after we could go down that road, we saw these rocks that had just been tumbled like little pillows, just huge rocks. And that really told us a lot about the speed and the force of the water that was coming down that scoured out that road. Planetary scientists for this image did some calculations, and they figured out that the water that moved these rocks along that eventually formed this conglomerate was moving along at about 3 feet per second. And that's a speed that would let it carry these stones along. And it also carried along, silt and sand and that sort of thing. And the water was somewhere between ankle and hip deep, just based on what they can see from the rocks. Here's a comparison with a similar type of stream here on Earth, just to give you an idea. These look pretty much alike. This is what planetary exploration actually will look like in situ. When you're there, you're picking up the rocks, you're going, this is really interesting. This is when you get down to the details. And so right now with spacecraft on Mars, we can get down to this level of detail, but eventually we want to send people to take a look. And then people have a little bit better way of saying, okay, yeah, that may look like a conglomerate and those may look like feldspar, but there's these things over here on this side. So it might not, it could be gravel. It could be anything. So people can actually reason their way through where a spacecraft really can't. It has to go through a computer program, and they do have AI on these things, but it doesn't always have the decision-making capability of a person. But you can tell that, water in both of these cases flowed along, carried rocks along, dried up, and eventually those rocks became a conglomerate. So this tells us a little bit about the existence of water on Mars in the past. And that fact right there is, yes, it existed. How it existed, that's another question. So Curiosity has been on the red planet, trundling around the surface since August 6th, 2012. My husband and I actually watched it from here in the Mountain Time Zone. It was actually close to midnight when it landed, and it was our anniversary. So we spent our anniversary watching Curiosity land on Mars. This is a selfie that it sent back. I'm trying to remember when this was, about a year or so back. And there's what's called a pediment of rock that it's drilled into, and that's what it's using to study some of the soil on Mars. Here's another view that Curiosity sent back a couple of years ago. Notice the rocks in the Dune Field. This is called Dingo Gap. And it looks pretty familiar, again, like a desert on Earth, but it's on Mars. This idea of Mars as a desert planet is a theme that has played out over all the missions we've sent to the red planet. They're looking for water, and what do they find? They find this desert planet, but there's these tantalizing details, these little images that you see that show that there used to be water there. All right, so let me step back a little bit. Humanity has sent a lot of spacecraft to Mars. This is just a collection of them. If there were Martians, they've got to be wondering why we're buzzing them with all these spacecraft. This is a general list of just the successful missions. There were a lot more. This began in 1960 and extends through this year. There are many others that didn't make it. I think I did a count one time, and it's close to 78 missions, I think, that didn't make all the missions that were ever sent. And of all of those missions, these are the ones that actually made it to Mars and returned some data. The others ones didn't make it for one reason or another. Sometimes they didn't make it out of Earth orbit, or they would get all the way to Mars and then have a crash landing, or something would go wrong with their systems. When I was in graduate school, the Mars orbiter was on its way, and then they lost contact with it as it was getting close to Mars. And one of my teachers was the principal investigator, or I'm not sure if he's principal investigator. He's one of the investigators on it. And he came out, and he had spent much of his early career on this spacecraft. And he came out and he was just white as a sheet. He said, we've lost contact with it. So they did eventually find out what the problems were, but it's still a huge loss, because people do spend years of their lives trying to send these spacecraft over there and get the science. Here's one of the first spacecraft images of Mars. This is from Mariner 4, which flew in the very early 60s. There's something that I want to point out here. So back in the day of Giovanni Schiaparelli, back in the late 1900s, he drew a map of, like I showed you in the beginning, of Mars. And he put on there that it looked like there were canali on this thing. And canali is the Italian word for channels. and which is fine. That just means some water flowed and it carved out a channel. Well, it got mistranslated into English and it became the word canals. And that really excited another scientist named Percival Lowell, who had built the Lowell Observatory in Arizona. And he was a little bit more interested in the alien side of Mars, shall we say. He was looking for Martians. And so to him, the word canals was meaning that there was intelligent life up there, basically digging up these things. And so that must mean there must be cities and spacecraft and on and on. He built this entire fantastic idea of Mars and Martians. And that really kind of took people by surprise. It also ignited a lot of interest in science fiction writers. And that's where you started seeing this big history of science fiction, and the Edgar Rice Burroughs books on down to the things that we see today, like the movie The Martian and things like that. It was a big cultural phenomenon. Well, this first picture of Mars from Mariner 4 doesn't show any canals, and apparently no life, and no princesses, and no spacecraft, and no nothing. It's just this bland looking thing. Another successful mission that got sent there was Mariner 9, and it arrived just as the planet was just enveloped with a global dust storm, so it had to wait until the dust storm cleared before it could do its work. And once the dust cleared, it sent back some of the sharpest images ever seen from Mars at that time in the 60s and 70s, better than anything taken from Earth, because of course we had been studying Mars from Earth using Earth-based telescopes like the ones at Lowell, like the ones in California. Everybody was, pointing at that planet. It was very hard to see great detail. But this picture showed impact craters on Mars, and that was a big deal. If you recall, there are impact craters around here in Arizona. If you've been to Meteor Crater, that's an impact crater. If you looked at it from space, it would probably look similar to some of these. It tells us something that smacked into the surface of the planet and changed it in some way. Many somethings, actually, since you see several craters there. Mars is pockmarked with craters, particularly in the south part of the planet. Well, the Viking missions flew in the 1970s. I'm kind of marching through a bunch of missions here. They flew in the 1970s, and they gave us even higher resolution images of the Martian surface. Now, this looks very familiar, doesn't it? It kind of looks like there was a river and a drainage system. I'm not sure I can do mousing. Can you guys see that? Anybody see a mouse? Anyway, there are these kind of tentacles going through the middle of the image. And that's kind of a drainage system. It was like a river, like something was flowing through there. It shows that something was there. But how long ago? They were still trying to figure that out. Here's a Viking orbiter image of a region called ARIES Valles. And this is an area where it looks like a catastrophic flood came through millions and millions of years ago. It scoured out the land, left behind these teardrop-shaped islands, which kind of formed around the craters there. The amount of material, most likely water, that came through would have been many times the flow of the Mississippi River. And so clearly there's evidence here that something flowed across the surface of Mars that was building up this evidence for water on Mars. We don't see any today, but there was water. This is there's also other features on Mars that aren't necessarily carved by water. This is the Viking Mission image mosaic of the Valles Marineris. This is a huge canyon on the planet. If you put it on our planet, it would stretch from New York out to the Pacific Ocean, probably maybe halfway to Hawaii. It's kind of tempting to think that this is what Schiaparelli or Lowell saw as a canal, but it's not clear that they saw this really well. It's actually a tectonic feature. It's not really a water created feature. I'm sure there was some water carving going with it, but it's a tectonic feature. It was meaning it was from the same forces that create earthquakes here on Earth and probably on Mars played a role in creating this region. In essence, the surface split and it cracked and it widened and it dropped. So if you see some kind of region, and there's places like this out in Utah called grabens, where the Earth is kind of split apart and the stuff that was in the center just drops down, and they call them grabens, which is a German word for grave. You kind of see this canyon here, which has been formed by the splitting of the surface, gradually widened over time. And it's very likely that water did play some role in shaping parts of this canyon. We just still need to find out what that was. And in the 1970s, we finally were able to land something on Mars. These are the Viking landers. They settled onto the surface of Mars in Utopia Planitia and Chryse Planitia, which are two areas on opposite sides of the planet. And what they found was a frozen desert. Nothing but rocks and sand as far as you could see. No water. They thought maybe they saw some frost. The landers did some chemical experiments on Mars soil, and what they were looking for there was for evidence of life. They thought, scientists that created these experiments thought, well, maybe we would see evidence of some kind of the remains of life or the chemical precursors of life. It didn't reveal much. I think to this day, people are saying, well, the tests were inconclusive. I know there are people that go back and renew and look at this information again, but to this day, I haven't heard anything that said, oh yeah, it's evidence of life. It's the remains of life or whatever. But that didn't stop the quest for intelligent life on Mars, for looking for it. It didn't stop it at all. People are still very interested to see if there was any kind of life. I guess I shouldn't say intelligent, but just any kind of microbial life on Mars. And so far, we haven't seen any evidence of that, but we're still looking. It didn't settle any questions Viking didn't about any kind of life. That was really left for future missions. Now, you look at Mars and you think, well, there's that green stuff. Is that vegetation? And that's really just the way that the image is colored. This is actually a Hubble Space Telescope image of Mars. Scientists haven't ruled out microbes. We just haven't found them. Today, Schiaparellis and Lowells, today's sort of young Schiaparellis and Lowells are studying Mars to find out about conditions on the planet and asking, could those conditions support microbial life? Did they in the past? Has this planet supported any kind of life, anything that we could think of? The evidence for that is going to be some kind of fossil or a chemical or biological residue. I'm not going to go too much into microbes here. I mean, that's still really kind of an open question about what we would find. But to find evidence of any kind of life, scientists have to look for places that would have been hospitable to life. So, or now, or in the past. So places where maybe there was water at one time, or there's a kind of a cool, train of thought going around about now, maybe it's in these underground geothermal areas that are, still heated by, some kind of underground heat. So that would be a place to look. We don't really have any way to measure that right at the moment. But you do have to be able to look in places that are hospitable to life. And that means that we have to know more and more about the geology of Mars. We have to study its landforms to understand how they arose, understand where life might have existed, or if the chemistry of the planet could have influenced life in any way. And I'm going to get a drink of water. So we do see other landforms on Mars than the ones I just showed you. There's a lot of volcanoes on Mars, a bunch of them. It does show that it was volcanically active in the past. This is the one called Olympus Mons, and it's the largest one on Mars. In fact, it's the largest one in the solar system that we know of. It shows that Mars has been affected by volcanic activity in the past. Now, when you look at rocky planets like Earth and Mars and Venus and Mercury, you kind of look at some different processes that shape them. And volcanism is one, tectonism is one, weathering is one. Weathering is caused by water. It can be caused by wind. And then there's cratering, and we've seen all of those at Mars. The big question is, if it had volcanism and if there was water in the past, could there have been life forming near underwater volcanoes or vents or something like that? We see that on Earth, obviously. We've seen those in a great many places where you have these black smoker volcanic vents coming out, and there's all these worms and clams and stuff around them. And they're perfectly happy in this boiling water with this sulfur-rich, mineral-rich water. So did the heat from volcanism provide warm places where life could form, where it could thrive? It's a good question. Earlier, I showed an image of flow features that look like river valleys. There's also images or evidence of what look like dry lake beds on Mars. And these are all good places to search for evidence of former life. That'd be true here on Earth, and it would certainly be true on Mars. This is part of what's called the Eberswald crater in a region called Margarita for Chaos, or Margarita for Sinus. It contains what looks very much like a Martian river delta. And these channels look like they fed into the lake that formed in the crater, and then for some reason it all disappeared. They're pretty clear evidence that some liquid existed during the early history of Mars. A lot of Mars scientists insist that that was water. Well, you can't look at the surface or even underground without also studying the atmosphere of Mars, and that's a pretty important area of study. To give you an idea about Mars, here on Earth, we breathe nitrogen and oxygen. On Mars, it's very thin. And it's made of carbon dioxide with a few traces of nitrogen, tiny bit of oxygen and water vapor. Totally different kind of atmospheric mix than we are used to. The Mars atmosphere has winds blowing through it. It does blow quite a bit, not quite the way we'd experience it here on Earth. I think the one scientific quibble most of us have with the Martians is maybe those winds were a little strong, but they do blow. The winds are almost a constant feature in the weather on Mars. And every so often, Mars will experience dust storms. They can be regional, they can cover the whole planet. They whip up for quite a long time and then they disappear. The winds also whip up these local disturbances called dust devils, which are like little tornadoes on the surface. And they're constantly spinning up and they race across the surface. One of the spacecraft that landed there, the Spirit rover, actually had a dust devil pass over it. It cleared off its solar panels so that it could get more power. That wasn't something they planned on, it just happened. This view is a dust devil that the Mars Reconnaissance Orbiter took from space. And it stretched a few kilometers up into the air, so it was actually a pretty sizable one. And here's what they look like on the planet. So if you're sitting on the planet, you see this dust devil goes by, is kind of what it looks like. The action of the wind, I talked about, the weathering on a planet, and wind will do some weathering. It pushes sand around and dust and basically creates just an amazing number of different types of dune fields. So this is one little dune field. There's many of them scattered across the planet. Another thing planetary scientists look for are craters. We talked about those a little bit earlier. Many of the impact regions on Mars are very, very old. But impacts still occur today. In fact, this one was created relatively recently, sometime between the year 2005 and the year 2008. The white material on the wall is water frost. And craters are important because when the impacts that create them occur, they dig up rock from underneath the surface and they scatter it around. So in some ways, they help our imaginary geologists on the planet by digging up rocks for them. We can't get there, so we expect these cratering events will dig them up for us. So then the next question is, are they volcanic rock? Are they sandstone? Were they laid down in the lake? Where did they come from? Those are the kinds of questions you answer by doing chemical analysis of the rocks. Or if you're walking across the surface of that world, you pick them up and look at them and go, oh yeah, it looks like a basalt or whatever. And the answer then gives you a history of the surface and what has affected it over time. Well, back to, there were two other rovers on Mars besides Curiosity. So there was the Spirit, which I just talked about. And this is a picture of the Opportunity rover. It spent much of its time exploring a region called Endeavour Crater and looked at Victoria Crater. This is an image of the region where Opportunity is now parked. We actually stopped getting data from this mission in mid-2018, so it was actually shut down. But it was, by all accounts, a really extremely successful mission. And from these images from that rover and from Spirit, you really do get a sense of, more of a sense of Mars as this desert planet. I mean, you just look in the distance at that thing. There's no water, there's no trees, there's nothing. And if you wanted to drive across it, you'd have to have those kind of tires that you use when you drive along on a beach, those big inflatable tires. It's not dead, not a dead world. It may be just frozen in suspension. Let's talk about Mars water a little bit. That's the big question everybody's asking. It's crucial to most forms of life here on Earth. We're pretty sure it would be on Mars. This is an image from the Mars Reconnaissance Orbiter of a crater rim on Mars. And it's pretty clear if you look at it that it's eroded. Something has flowed down the side of those walls, of those crater walls. And when they first took the image, they thought maybe it had flowed recently, like within a few days. So these yellow arrows here point to some dark areas that seem to come and go as the seasons change. I mean, it looks to me like if you poured water on sand, it would get dark, and this is what it would look like. It could be places where underground ice is melted. What's melting it? That's a good question. Why else would water be coming out? What's forcing it out? If that is water ice, which some scientists think it is, then when it melts, the water flows out, it wets the soil, and then it immediately freezes or it dissipates in the very thin atmosphere. So planetary scientists, they use images like this and other images to pin down how deep ice is buried. It is known that there's a lot of ice buried underneath the surface of Mars. How salty is that ice? If it was from an ocean, how salty would it be? What causes it to melt and flow? Those are all things we want to know. Well, if Mars had water in the past, and the evidence seems to think that it did, what happened to it? Why is Mars this desert planet? Did it start out that way? What caused the water to leave the surface? These are all questions that we're trying to answer with the current fleet of spacecraft. And the answers are not simple. There's a lot of evidence that early Mars could have been warm and wet. This is kind of one of my favorite paintings from a friend of mine. We don't know that it looked like this, but it kind of makes it feel homey, to us. Well, it was watery in the past. One piece of evidence for water on there is the existence of minerals on the surface that only could exist because water was present. They either formed in the water or the water had something to do with them. And of course, there are things that look like riverbeds and lake beds on the planet. I showed you images of that. There are also ideas that Mars could have been covered by glaciers, and that's been kind of a recent kind of discussion going on in the planetary science community. And that if it was covered by glaciers, there would be meltwater maybe carving out underneath the glacier to carve out some of the features we see. So it's not completely obvious that it was, a watery ocean world in 3.5 billion years ago. Those are all questions we have to answer. And so some people are saying, well, what if it was glacier ice? And so then you kind of have to think about that. But something happened. We know something happened to remove or hide most of that early water, no matter what shape and form it was in. Today, we know there's still that water on Mars. I told you about the ice at the poles. There's frost on the ground. There's ice frozen into the surface, kind of a permafrost layer. And there could be massive reservoirs underground. Maybe they're being heated by residual heat from the center of the planet. That's a really iffy kind of supposition. But liquid water cannot exist on the Martian surface. The atmospheric pressure is too low. The temperatures are well below freezing, so it would freeze right out, or if it just sublimate. So how could it have existed in the past? And what happened between now and then? That's the question that the Mars MAVEN mission is trying to answer. MAVEN stands for Mars Atmosphere and Volatile Evolution Mission. And it's been studying the atmosphere for several years now, looking for evidence of climate change in the past, looking for the loss of hydrogen to the atmosphere, the loss of oxygen and water to the atmosphere, and then try to figure out when did that start happening, and then try to correlate that with something that might have happened in the past that turned Mars from a warm, wet place to a dry, dusty desert with ice. Scientists suspect that Mars is not a geologically dead place. It's possibly just in some kind of hibernation. And it periodically wakes up and goes through cycles of heating and thawing. The heating melts the ground ice and you get flooding. Then the planet goes through a chilling cycle and everything refreezes. This too could be detected by MAVEN and also by studying subsurface ices beneath, like the permafrost. So today, the search for life and conditions where life can thrive in the new frontier on Mars is ongoing by studying the chemistry, by studying all of the processes that change the surface of Mars, by studying the atmosphere. Earth wasn't explored in a decade or a century. It took hundreds of years, and we're still finding some places that are unexplored, largely unexplored. And I suspect it will take a very, very long time before we really know Mars as well as we do Earth. And to really know Mars, we're going to have to do like we did on Earth. We're going to have to explore it in person. And when we finally do land people on Earth, well, it's going to be as exciting and momentous as Neil Armstrong's first steps on the moon in 1969. So I have to ask, who's going to take those first steps onto the Martian surface? Well, we don't really know yet. We've seen a lot of talk about Elon Musk wants to send people up there. He had this idea of sending married couples up there. The Chinese want to send people up there. It could be a multinational crew. It could be Chinese and Americans. It could be Chinese and Russians. It could be Indians. Whoever it is, they're likely training right now. There are people around the planet working in places like Utah, on the slopes of Mauna Kea in Hawaii, northern Canada. There are various places on the planet where they go and live and work and train as if they were on Mars. They isolate themselves. They're in these really, really extreme conditions for our planet. And those extreme conditions on our planet are still not going to be as extreme as the ones on Mars. Again, they're going to have to get used to living on a world that has a carbon dioxide atmosphere. So they're going to have to wear these suits. There's been a lot of talk about what kind of suits they're going to wear. It's going to be like regular spacesuits. It's going to be something kind of slimmed down. All of that's sort of in the details, but that's what they're going to have to learn. They're going to have to search for their water. They're going to have to create their own oxygen to breathe. They're going to have to live with a lower gravity. Martian gravity is 38% of Earth's. So it's going to be very different for them. Our bodies were not made to be in 38% gravity. We grew up in a different gravity well. And so we have to get used to that. There's a million things I'll have to get used to on Mars. So kind of like living on an Earth desert, it's going to be like that, but with a poisonous atmosphere and a really light gravity. And probably other conditions that we really need a lot more information about. So that's why we send robotic probes. Those are cheaper than human lives to send. They're kind of like the scouts. We're sending them out to check out the territory ahead. And we really need all the data we can get before we start sending people there. Well, today there are 3 more spacecraft on the way to Mars. You knew I'd get to this. And they're going to arrive in February 2021. So this is Perseverance, which is NASA's project. You can see it here at JPL before it was packed up and sent to Florida for its launch earlier this summer. Perseverance is going to land in a place called Jezero Crater, and its mission is going to be to rove around, to take pictures, listen to the environment. It's the first time anybody sent a microphone to Mars. They didn't think of that before, or they did, but the weight restrictions were there. They're going to sniff the atmosphere. They're going to look for evidence of water. Again, scouting the territory ahead. Dig up and analyze geological samples, just like our geologists would do, and employ a neat little Martian helicopter called Ingenuity. So if you look underneath the belly of the spacecraft, kind of on top of that, it looks like a tin foil or kind of a protective wrapping between the wheels. There's a little helicopter under there, which you can see tucked under the belly. And that's going to get out and fly around. It'll be the first helicopter on Mars. And the idea of this is kind of like the idea of drones. I don't know how many of you read the story recently about all the drones they're sending out to the fires west of here. They're sending out drones packed with cameras and IR equipment and that sort of thing. Well, this little guy is going to fly over the surface of Mars and go to places that the rover can't go. Or it might go to places that they want to send the rover to, but they don't want to send it till they know it's safe. So first helicopter on Mars, that's going to be the Ingenuity helicopter. And I can't wait to see that one happen. The United Arab Emirates launched its Hope orbiter. So it's the first Mars spacecraft for that country, the same week that Perseverance went up. So I don't know if you remember, a few weeks ago, there were 3 big launches to go to Mars. It's the first planetary mission for that country. Hopefully it won't be the last. And interestingly enough, that spacecraft was built here in Colorado at the lab I used to work at called the Laboratory for Atmospheric and Space Physics. They built a lot of spacecraft and instruments there. They worked on a number before I got there, and they're continuing on the mission. In fact, the MAVEN mission is controlled from there as well. So the HOPE mission will study the weather cycle on Mars, both day and night, and also over the course of a year. It will focus on events that happen in the lower atmosphere, like those dust storms and the dust devils I talked about. And like the MAVEN and MOM missions, and the MOM mission is the Mars Orbiter mission, and that was launched by India a couple of years ago. It's going to focus on why the planet is losing its hydrogen and water and oxygen. Why is that all being lost to space? And it probably can't be reversed, but at least they want to understand how it happened. So the HOPE mission is going to arrive in February, about the same time as the Perseverance, and the Chinese mission called Tianwen-1. And here's a picture of that one launching. They launched it the same week that the other 2 went. And it's going to deploy an orbiter and a lander on the red planet. And that will basically continue our scouting the territory ahead, our exploration of the Martian surface, the atmosphere, and the long-term weather. So we're going to have 3 spacecraft, well, at least 2 major spacecraft, joining MAVEN, joining MOM, to study the atmosphere, which is way more than we've had before. And of course, the Chinese have kind of a longer-term goal here. They want to land people on Mars, possibly within the decade. And a couple of years ago, I worked on a project in Shanghai for a science museum there. And I went over there twice and met with the science museum people. And they were really proud of this. They couldn't tell me the name of it. You know, I don't know that either they didn't know it or they didn't want to tell me. But they're basically, you know, we're building a Mars mission and we're so excited about it. And they actually had a few little drawings that they showed me that were not very detailed that they were going to put into their exhibit, but they weren't going to show me what they were putting in. And I don't know, I think maybe some of it was they were still working on it. But again, China is very proud of its space program and they want to go to Mars. And so it might be that we'll all get up there together, or it might be that a human mission to Mars will be an international endeavor, because it does cost a lot. And it's going to take a lot of different minds and mindsets and talents to put something like that together. Well, oh yeah, here's a picture of what they think their people on Mars are going to look like. Well, that's a look at the quest for Mars. There's so much more we could talk about with Mars. I'm happy to answer questions about it. Do stay tuned next February when the 3 spacecraft arrive, and that'll be starting the next wave of Mars exploration. And I'm expecting we're going to see a lot of really good images. And I'm kind of excited to find out if we're going to hear the first sounds from Mars, because we didn't have those before. And so now we'll hear sound, we'll have images, we'll have chemistry. We're starting to really learn more and more about this planet that we've only just been able to start exploring in the last, well, about 50 years or so. Thank you.
Cece, as always, you have some fantastic research that goes into all of these things. And we have some questions that came in from the audience.
Okay.
And the first one is from Lily. And she asks, does weather on Mars tell us anything about weather on Earth?
Well, not in the sense that if the wind blows there, it's going to blow here, but it will tell us something about how an atmosphere evolves. And really looking at the history of the climate might tell us a lot more about what we might expect here. But again, they're 2 different atmospheres. So we have this, really nice nitrogen, oxygen-rich atmosphere that we're all breathing here, but there it's going to be carbon dioxide. A lot of people have asked me, well, wouldn't it be more likely to look at Venus and say, isn't that the future of Earth? And that's a whole other argument. But I think I don't think you can look at Mars and say, oh, that's the future of Earth. But in large scale structures, in terms of it having an atmosphere and having actions that go into it, they're both similar, but they're not exactly identical.
Okay, Rylan asks, does Mars have water ice? And if so, where has it been discovered? And is it evenly distributed across the planet, or is there more of it in a specific spot than others?
Well, there's a lot of it in one of the poles. I think it's the South Pole. I'm going to screw that up. It's one of the poles. And there's also this idea that there is this subsurface ice. I'm not sure that we have an exact amount on that. So I can't quote you an amount, but there is quite a bit of water ice. How it's distributed is sort of another question.
Okay, Alex has asked, is Ingenuity remote controlled or automated?
I think it's automated. It's programmable. I think I did read that. Ken, do you know? Can he answer that? I'm not sure Ken would know, but I think it is. I think it's, they're using AI to help program it, and then it's going to make decisions as it flies along and then come back. But you can't control it from Earth. I mean, that's a 15 to 20 minute time lag. So it has to be controlled some other way.
Kind of hard to fix your drone when it's going sideways in the 15 minutes in between.
Well, yeah, I mean, that's a problem. Yeah, I need to read more about that. I'm sorry, I didn't actually look into what the software control was for that.
Is it 15 minutes both ways? That's the lag between?
No, it's actually, depending on where the 2 planets are in their orbits, it can be as little as around 10 minutes, I guess, up to about 20 minutes or so.
Okay, Clara asks, does Mars have clouds?
Yes, it does. High thin cirrus clouds. I mean, just of that, and then obviously when those dust storms you have clouds of dust, but yeah, there are a couple of images, and I'm trying to remember from one of the rovers that they took, and it shows these really nice little clouds up there.
All right, Matt has asked, is Elon Musk's idea about nuking Mars to terraform it realistic, or is he joking?
God, with Elon, I have no idea. He throws a lot of really interesting ideas out there. I don't think so. For one thing, once you nuke someplace, you have this huge problem of contamination. And so unless he's got some kind of clean nuke that he's developed, I don't think he's being totally serious about it. He does want to get people there, though. I do know that. I think he wants to be the first one of the first people to go there. And he said he wanted to die there, but not in a crash.
So do you think that the future of manned space exploration is going to follow very closely with the commercial development of space exploration, or do you think that it'll be an independent agency like a NASA, or a partnership like we've seen with SpaceX and the Demo 1 team?
Well, I think if we're talking about international, I mean, if we're talking about space exploration, like going to another planet, it's really expensive. And I know, you know, when I was growing up, it was basically NASA's line of, well, we're going to partner with lots of people. I mean, in the very beginning, NASA was the only game in town, well, along with the Soviet space program. But, you know, as we find out how expensive and complex these things are, not everybody that's good at this stuff is at NASA. You know, NASA can only afford to hire so many people. Sorry, Ken. And so, you know, you have these really smart people out there in industry, and NASA has always cooperated with industry. So I do think it's going to be a partnership. Whether it's going to be all of the countries pulling together or we're going to have the space race, that's sort of another question. Might be a race with Elon for all I know.
Have you seen that technology that we've used on the moon has been useful to us in being repurposed on Mars, or can we repurpose technology that we're taking to Mars and use that for future moon missions?
That might be more likely, that second half. I mean, the technology we used to go to the moon is now how many years old? You know, I mean, yes, there's certain basic technology for life support and that sort of thing that you know, we can obviously make better over time, and that's going to be used to go to Mars. But we're going to have to come up with a lot of new things. I mean, for one thing, they're going to be Martian people, the people going to Mars are going to be in space for a long time. They're going to be subject to radiation. They're going to be subject to low microgravity. Our bodies weren't made for that. And so there's an awful lot of research going on today about how long you can be in space and still not turn into a jellyfish. And, you know, ask any astronaut who spent a lot of time in space, and they're going to tell you, it affected this on my body, it affected that, their eyes, their brains, their hearts. So we're going to have to come up with something that induces some sort of gravity on this spacecraft in order for them to make it there and not be jellyfish, you know, at the other end.
Dr. Ken says NASA's website indicates that flight controllers at JPL won't be able to control the helicopter with a joystick. Communication delays are an inherent part of working with spacecraft across interplanetary distances, and commands will need to be sent well in advance, with engineering data coming back from the spacecraft long after each flight takes place. In the meantime, Ingenuity will have a lot of autonomy to make its own decisions about how to fly to a waypoint and keep itself warm, which I suspect is a problem with batteries, right?
Right. I forgot to mention that. Yeah, because I had read this whole treatise about, you know, how they're going to keep the thing warm, and if those batteries drop below a certain percentage, then the whole thing just goes to sleep. But yeah, I knew they couldn't control it, you know, like any kind of, you know, Xbox control or anything like that. It really does have to have some amount of AI autonomy to be able to do that. But I mean, to me, it looks like a really fancy little drone, and so that it's going to have some kind of decision-making property on its own. So thank you, Ken.
Some of the images that you've had in your presentation, you can see some of the quality differences. Have they sent cameras capable of taking like a 3D panorama, and are those being used in science education now to teach people about landscapes of different planets?
I don't think so. The ones that I've seen that have been 3Dized were done here in post-production, essentially. I mean, I saw a really lovely one that was done at New York, Hayden Planetarium, where they did quite a lot of work to make it look like you were looking at a 3D image on Mars. And it was one of the same panoramas I downloaded from NASA. So I don't think there's a camera I don't think there are. It'd be cool if they did.
So you've written a lot of science books, and you've done a lot of science educating and a lot of science content. What has been your favorite science mission or planet or place to write about or to document?
Well, aside from Mars, the very first one I ever covered was Saturn. So way back in the day when I was this scared to death little reporter, they sent me out to JPL to cover the Voyager Saturn flyby. So Voyager 2. Going past Saturn, this was in 1981, I think. That's embarrassing. Yeah, I went to my you know, one of the editors that's got at the Denver Post, that's where I worked, and said, I want to go cover this thing. And they said, okay, we can't pay your expenses, but we'll give you a press pass. So I cobbled together some money and flew out there and did it. And it was the first time that I realized how complex some of these missions could be. And so I was with a number of the Voyager scientists. A lot of them were at the University of Colorado. I'd been there, and I got a chance to talk with some of them. And so then I made a point to go to the next 3 flybys. And so it was really more about the Voyager mission. And yeah, they were going to cool planets, but it was this group of people sending this spacecraft out there and getting really cool stuff billions of miles from Earth. And that kind of followed all the way out through New Horizons. And the PI of New Horizons is an old grad school friend of mine. And so obviously I had to go out for that. So we, Pluto, right? It's got to be Pluto. So I think those two. And then, aside from that and Mars.
Where do you think, besides Mars, where do you think that we're going to end up next? With robots or manned missions?
Oh, probably Europa. I think Europa. Yeah, show me that. You want me? I don't have my Mickey Mouse hat. Oh, here you go. I got an animal for you. Anyway, no, I think it's going to be Europa. There's an ocean under that icy surface, and it is fairly close. The big problem with Jupiter, though, is there's that huge magnetic field, high radiation. It's going to be really dangerous. I don't think people are going to be walking on that surface, but certainly more spacecraft to find out what's going on underneath that surface. And I've seen these mission plans for sending these little robots underneath the water, underneath the ice, to go down and see if they can find life underneath that surface.
Are there unique challenges that present themselves when, with Europa, you have a liquid surface as opposed to most of the stuff that we've been to, which is rocky? Do you know?
Europa's got an icy surface, so.
Oh, we have icy. Okay, great.
So yeah, it's icy, and I guess you just want to make sure you don't land in one of the cracks or something, because the surface is there's a lot of gravitational pull between Jupiter and the outer moons, and so that one is not flexed as much as Io is, but you could see surface cracks developing and lose your spacecraft in there. And Enceladus would be another one. That's actually out at Saturn. That's also got jets of material shooting out from underneath the surface.
So what's your next book going to be on, CC?
That's interesting. You should ask that. I'm probably going to be rewriting one of them. I have a book out called Astronomy 101, and I asked the editor, do you want me to send you the latest updates? And he's going, well, we might want to have you do a new one. So stay tuned. My last one, yeah, it came out in the UK in November. So that was the book about observatories, the discovery of the universe. And it was supposed to come out, big splash and everything in March. And then, as you know, in March 15th, all the doors closed. Everything stopped. The schools closed. The bookstore, everybody closed. And so here's my book just sitting there. And they sent me 10 or 15 copies, so I do have some hanging around. And they're starting to sell them now. But yeah, it was kind of a bummer. All of us who had books that came out in March, we're just kind of screwed. So yeah, messed up.
So besides your books, who has written your favorite book on science or space exploration?
Carl Sagan. I read his books more often than anything else. He was the one that inspired me to start writing about it. The first time I got started interested in astronomy was from my dad, and I was a kid. And then when I got out of college and realized I wanted to be a writer instead of a teacher, which is they're kind of similar jobs, but I started watching this show called Cosmos in 1980, I think. And I'm going, well, I can do that. I can tell these stories. But I was totally fascinated with it. And then I had a chance to meet him a few times, and he was totally inspirational. So I ended up going through all of his books. Most of it, I think almost all of his books I read. And then Cosmos was the one and Contact, I think that was pretty good as well. So yeah, Carl Sagan.
All right. Well, one last question. Where can we find out more about you and your work?
Thespacewriter.com is my website. I also have a fairly big amount of work that's been published on my company's website called LochNessProductions.com, which is linked to from the Space Writer. And that's my company that my husband and I formed a long time ago to market materials, content, and that sort of thing to planetariums and science centers. And it's sort of evolved now into me working with science centers and on exhibits and that sort of thing. So yeah, that's what I do.
Well, CC, we so appreciate you and all your work bringing all the scientists together to Fort Collins
Sure.
Comic-Con, and we'd love to have you back again. Do you have another con or a series of presentations coming up besides the ones tomorrow?
Not that I know of. Not that I know of. I just finished one for an immersive filmmaking group. That's all over with, but no, not that I know of. I mean, things are so slow to wake back up now. It's like everybody's sort of waking up going, okay, maybe we can do this online or whatever, but it's just been an odd time all the way around.
Well, that's all the more reason why we're thankful you're here.
Yeah, I will see everybody again tomorrow.
Yes. So tomorrow, there are a slew of different science panels that are occurring. And there's a Q&A that starts at 1 p.m. with all of the scientists that we've seen so far. Dr. Claire Raftery, is going to be presenting the sun like we've never seen it at 11 a.m. And then we have other panels as well that are not science related, but still just as fun.
Yeah.
3 p.m. Becoming the GM that your players wish you were, and at 5 p.m. Q&A with Rob Paulson and Maurice LaMarche, Pinky in the Brain.
Yeah, I'm looking forward to all that. Yeah.
Yeah. Are you a Pinky in the Brain fan, Cece?
Not really, but I just kind of like to look in on these things because sometimes I'll find things that I've missed and I'm going, why did I miss that? So kind of like Discovery. I didn't watch that till it was the end of its second season.
It's a good show. And another one of our resident scientists, Dr. Aaron, is an advisor for Star Trek series now. So
I'm so pleased for her on that. Yeah, that's great. We have somebody on the inside now.
And Jeff says, thanks for doing this, CC. This is fantastic. And like I said, and you come back anytime. We love to have you drop the knowledge on us.
Well, hopefully we get to do this next year in person,
Love to. Yeah. We'll have you back then.
All right. Thanks, everybody. All right. Bye.